24th of March 2019. Real quick, beyond 2012, why the world didn't end. Editor's update, September 20th, 2017. It says various people are predicting that world will end September 23rd when another planet collides with Earth. The planet in question, Nibiru, doesn't exist, so there will be no collision. Okay, so with that said, I don't know anything about this, but I did see something that was interesting, and I did wonder what was going on with the poles. So I did check this out. You know, if they're telling us the truth, great. If they're not, there is something interesting going on with the poles, and a couple of models I'd like to show you about that. Now, you might have seen this in the news. Are the Earth's magnetic poles moving? How do navigators adjust to this change? They are moving. The good thing is the Earth's geographic poles are generally right where you expect them to be. Now that'd be concerning if they eventually do move, or if there has to be a shift of mass in order to balance out the magnetic properties of the Earth. I don't know if that would be possible or necessary, or if, well, I'll let you draw your own conclusion. I just want to show you these models real quick. The first model, which is pretty interesting, it has to do with the nuclear magnetic resonance. And if you see here, when there's a let's see here, I'll just show you. Okay, so they're showing a slight push. You see the wobble and the oscillation occurring. Okay, now this is pretty interesting in my perspective, because this is exactly what they're suggesting the Earth is doing. It's not perfectly rotating on the perfect axis. They're suggesting it's wobbling. And that little tap of the finger, I kind of wonder what that would be to our Earth, because we are seeing a magnetic pole movement. And so I would wonder what it's having that outside effect. Now, in the other video, it'll give you an idea what could on a very small nuclear level. But show you a little bit more of this here. This is a compass magnetic resonance, and essentially the vibrations on the outside vibrations here can affect the compass needle, but they have to be the same hertz as the compass when this compass starts to wobble, I guess. Like I said, I'll let you watch the whole video, but if you see the behavior, you kind of almost wonder if there's a stressor that's also causing the wobble. Let's see if he leaves it in place. Okay, so you see this now is activated, and when it's deactivated, it wobbles. So this is a resonant B1 field. That's what he's saying. Now you see how when he turns it up and he adjusts it just right, this thing completely turns on its side. So finally, what I'm going to show you here is this is an RF signal on two atoms, and they're showing where the atom's energy is and where the actual magnetic field is pointed. So there's an RF pulse, and they're saying the right strength and duration has to be just right. And essentially what you're going to see is the decrease of magnetic field. So that's neutralized.
But, as both protons are photons, there is a new transversal magnetization.
So there's the new transversal magnetization. So that's all I wanted to show you. Take a look at the videos. If you're taking physics, ask your physics teacher, hey, what's this about? I can't really tell you anymore. And how does it apply with the Earth? Because like I said, there's emergent properties, emergent systems. There are things that that aren't the same on the atomic level. So if you enjoyed the video, give me a thumbs up. Thanks for watching. And if you have any comments, just let me know. I'm kind of curious about this stuff myself. Thanks for joining me on The Curve.